Hello everyone, myself Prashant Kalidas Kavle. I am assistant professor working in mechanical engineering department, KK Wag Institute of Engineering Education and Research. So today's topic in mechatronics is poles and zeros of a transfer function. So after completing this session, participant will able to explain what is meant by poles and zeros of transfer function. Then they will find out exactly, they can able to solve the numericals to find the exact values of the poles and zeros for the given transfer function. And once they find out, they can able to plot them on graph. That graph is known as a S domain. Okay, so we'll see. So what is meant by poles and zeros of transfer function? So first we also assume that you should know the transfer function. It is nothing but the Laplace transform output upon Laplace transform input, C of S, control output, R of S, reference input. So they both output and input are represented by some mathematical expressions or polynomials. They are represented by polynomials. So numerator polynomial and denominator polynomial. So whenever we talk about the polynomial, so your transfer function consists of a numerator polynomial and denominator polynomial. That's it. Now what is meant by pole? When we take a denominator polynomial and equate it to the zero, we'll get some roots. If you put down that value of roots in that denominator polynomial, that times your value of a denominator polynomial becomes a zero. So anything upon zero becomes infinite. So it is a situations where the transfer function value becomes infinite. That times the roots of this denominator polynomial is known as the poles of transfer functions. So we'll take one example. Consider in front of you, this is one transfer function, numerator polynomial, denominator polynomial. We have to find out its poles. So we'll take denominator polynomial and equate it to 0. So what is the denominator polynomial? S plus 3, S plus 4 is equal to 0. Now we'll find out the roots for what are the possible values of S. So possible value of S are 0, minus 3, minus 4. Hence, poles are 0, minus 3, minus 4. So we are plotting them on some graph. So whenever we talk about the graph, so it has the x-axis, it has the y-axis. So x-axis is represented by a sigma and y-axis is represented by j omega, and poles are represented by cross. So what are the values? 0, hence this is first pole. What is second? Minus 3, so this is minus 3. And what is the third pole? Minus 4. So these are represented. So we got the idea. So whenever we have to find out the poles, we take denominator polynomial, equate to 0 and find out its roots. It calls as a poles. They're represented by a cross on a S-plane. What is the S-plane? It consists of a x-axis and y-axis. X-axis is known as real axis, y-axis known as imaginary axis. Now what is meant by zeros? Now for poles we consider the denominator polynomial, for zeros we consider the numerator polynomial. So when we find out the roots of a numerator polynomials and we put down that roots value in that numerator polynomial, that times the value of numerator polynomial becomes a 0. 0 upon anything? 0. Hence the situations where transfer function becomes 0, its value becomes a 0, that time the roots of a numerator polynomials are called as the zeros of a transfer function. Simple. So we'll take same example. So what are the same example? We have to find out the zeros. So what are the zeros? So we'll take numerator polynomial, equate to the 0. So s plus 2, s plus 4 equal to 0. So what are the values? Values are 0, minus 2, minus 4. Okay. Now we'll plot on the graph. So zeros are represented by a circles. So what is the first 0? 0. What is the second 0? -2. What is the third 0? -4. So they are represented by a circles on S-plane. Simple. So poles and zeros plot. The diagram obtained by locating all the poles and zeros of the transfer function in a S-plane is called as a poles zeros plot. The S-plane has a two axes, real and imaginary. Since x-axis stands for the real axis and shown by the values of sigma. Similarly, y-axis stands for and represent imaginary axis j omega. So we'll take above example. There are three poles and there are three zeros. So we plot them, combine. So we have the five values. Okay. So this is known as a poles and zeros plot. Thank you very much.